All right, if you would please grab out your Simply Similar Unit Assessment Review, and we're going to go over all of the questions on here. We're going to start with question number 1, where it's asking us, what are the 3 characteristics do you know that are true about any similar figures? In no particular order, your 3 rules to be mathematically similar, so I'm going to write that up here. Mathematically similar are as follows. You need to have the same general shape, but different size. They need to have congruent, or your corresponding angles are congruent. And your corresponding sides are proportional. So corresponding sides are proportional. Moving on to question number 2, 3, 4, and 5 is that we were asked to calculate each of the unknown dimensions of rectangle B if they have the same shape as rectangle A, where rectangle A has a width of 18 and a height of 24. We need to understand that it's written as width by height, so your answer for your width is always going to be first. When solving questions 2, 3, 4, and 5, I'm going to use proportions to set these up. So for number 2, I'm going to go over here. I'm always going to use width over height. And I'm going to start with a piece of information that I'm given in my problem already. And I know that it is 18 by 24. Then I'm going to look over at question number 2, where the first number is 6, which if you look back up at the top, it is known as my width over. I am missing that last piece of information. I can use cross product, or with this one, it's easy to scale it down. 18 goes down to 6, or be scaled down by 3. And what I do on top, I'm going to make sure I do the same thing on bottom. And 24 divided by 3 is going to give me 8 centimeters. I'm going to start with the same exact type of ratio with width over height for question number 3 to have 18 over 24. This time I have my second number. So when I'm setting up my proportion, 3 is going to go on bottom and X is going to go on top. 24 goes into 3 8 times, or not 8 times. It goes down to 23 by 8. So 24 divided by 8 is 3. And what I do on the bottom, I'm going to do the exact same thing on top. So I'm going to do 18 divided by 8. 8 is going to go on the outside. 18 is going to go on the inside. 8 can go into 18 at least 2 full times with 2 left over. Goal in division is to get to 0, so I'm going to add a decimal and a 0. Bring the 0 down. 8 can go into 20 2 times at 16 with 4 left over. Add the 0, bring down the 0, and 8 can go into 45 full times with nothing left over, giving me the final answer of 2.25 centimeters. My next one I'm going to do is looking at number 4. I'm going to still use the same width over height again of 18 over 24. I'm given my second number, so it's going to be X over 32. Well, 24 cannot go into 32 nice and easy, so I'm going to simplify 18 over 24, and I'm going to simplify them both by 6. 18 divided by 6 is 3, and 24 divided by 6 is 4. 4 can go into 32 by 8, so 8 times 4 can give me 32. And then 3 times 8, sorry, not 4, 3 times 8 is going to be 24. So this should be 24 centimeters. My last and final one here is number 5 of width over height. And I'm going to still use 18 over 24. And I have the first number this time of 12 over X. Let's see, can I move all of this? Whoops, oh, nope, sorry. I thought I could try and move it. Did not work. All right, so 18 over 24. 18 cannot go into 24, so I'm going to divide this by 2. Half of 18 is 9. Half of 24 is 12. 9 still cannot go into 12, so I'm going to divide it again by 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. 3 can go into 12 4 times, so times 4. And I'm going to do the same thing on the bottom. So 4 times 4, which is going to give me 16 centimeters to end. All right, looking over at number 6, the map of the city is giving me the scale below. It is telling me that half of an inch is equal to 3 miles. If Derek lives 13 miles from the shopping center, how many inches apart is Derek's house from the shopping center on the map? All right, so I'm going to set myself up a proportion once again, and I'm going to do inches over miles. And I always personally start with what my problem gives me of 0.5 inch over 3 miles. And I use this to help me set up the final part of my proportion. And Derek is told that he lives 13.5 miles, which is going to go on the bottom with the other miles. And I want to know how many inches he lives away on the map. I know that 3 cannot go into 13.5 nice and easy, so I'm going to do something called cross product, where I'm going to do the top left times the bottom right, and then divide by the number that's left over. So I'm going to do 13.5 times 0.5, which 0.5 is the same thing as 0.5. You do not have to line up your decimals when you are multiplying with decimals, but this one just happens to line up, so it makes it nice and easy. 5 times 5 is going to be 25, carry the 5. 5 times 3 is 15, plus 2 more is 17, carry the 1. 5 times 1 is 5, plus 1 more is 6. You do not bring your decimals straight down. When multiplying with decimals, you need to see how many place values you have behind the decimal. In this case, there are 2 in total. So I'm going to create my decimal, and I'm going to loop it once, loop it twice, to give me 6.75 as the answer between those two. And then you still need to divide it by 3. So I'm going to go over here. The bottom number goes on the outside. Top number goes on the inside. Bring your decimal straight up so that way you do not lose it. 3 can go into 6 2 full times with nothing left over. Bring down the 7. 3 can go into 7 2 full times with 1 left over. Bring down the 5. 3 can go into 15 5 full times with nothing left over, giving you your final answer of 2.25 inches on your map. All right, we're going to do the exact same thing for this problem, and I'm going to go ahead and turn all of my fractions into decimals to make it nice and easy. So instead of having 1/4 of an inch, I'm going to think of my quarters, and 1/4 is equal to the same thing of 0.25 inch is equal to 1 foot. The blueprint shows the design of the room of 4.5 inches. Well, we're going to change that to 4.5 inches long, and it is 3 1/4 inches wide. I'm going to change it to 3.25 inches wide. I want to know what the actual dimensions of my room. So I'm going to take my paper and I'm going to split it in half, and I'm going to say long ways here, and I'm going to say width wise here, or wide, because I want to figure out what are the dimensions of my new room. Now, just like I did above, I'm going to create my proportion, and I'm going to have 0.25 inches over 1 foot for both of them, and I'm going to use that and set up the rest of my proportion. Well, the length of my room is 4.5 inches, and I need to find the foot. When you do cross product here, 1 times 4.5 is 4.5. Now I just have to divide it by 0.25. 0.25 is going to go on the outside, and then 4.5 is going to go on the inside. You cannot have a decimal on the outside, so you're going to have to move your decimal over. So I'm going to go 1, 2. What I do on the outside, I have to do it the same thing on the inside. Bring it out, and then I'm going to add in a 0. 25 can go into 45 1 full time. And then I have 20 left over. Bring down the 0 to give me 200. When you are thinking about your 25s, think of your quarters. So 25, 50, 75, 100. Still not there. 125, 150, 175, and then finally 200. So 25 can go into 200. 1, 2, 3, 4, 5, 6, 7, 8. It can go in there 8 full times with nothing left over, meaning that the length of your room is going to be 200 feet. Not 200 feet. Ooh, I'm sorry. 18 feet. I don't know why I was thinking 200. 18 feet. All right, we're going to use the same setup of proportion. So 0.25 inches over 1 foot. And I am told that my room is 3.25 inches wide. And how many feet is that? We're going to do the same process here of 1 times 3.25, which is the same thing, and then divide by 0.25. So when I use my ratio of 0.25 on the outside, 3.25 on the inside, move it twice here, same thing on the inside, bring it up. The difference between the last one and this one is you do not have to add a 0. 25 can go into 32, 1 full time. When subtracting, you're going to have to borrow and carry. 5 can go into 12, 5, 6, 7, 7 times. And then bring down your 5. 25 can go into 75 3 full times with nothing left over, meaning that the length of my room is actually 13 feet. So your room is 18 by 13 feet. All right, looking at question number 8, the figures are similar. Determine the missing measurements. So I'm going to go ahead and grab out my highlighter because I want to figure out my corresponding sides. All right, so I'm going to go ahead and start highlighting A to B. Oh, that's really large. There we go. A to B is proportional to P to R. No, A to C, sorry, is proportional to P to R. AB is proportional to PQ. And then last, BC is proportional to QR. All right, so I'm going to go ahead and write that in here. I'm going to say AC is similar to PR. AB is similar to PQ. And then BC is similar to QR. You can highlight these if you want. Oops, nope, that's not what I wanted to do. Highlight, there we go. You can highlight these in the colors that you had on your paper, so that way you know which ones are which. But those are your proportional sides. Then when you start looking into your proportional angles, this is where we start looking here, where angle A is equal to angle P. As in, if A is one number, P is going to be the same thing. Angle B is equal to angle Q. And then the last one, angle C is equal to angle R. All right, using the information in your triangles, you need to find the missing measurements for each of your things and angles and sides. All right, so here's this. When you see something that reads and looks like this is what it's saying in words. It is asking you, what is the measure of angle A? So we got to go back up here to to our first triangle of A, B, and C. You need to remember that inside of your triangle, all of your angles, all of them add up to be 180 degrees. So if I know this angle of angle B and I know this angle of angle C, add those two together, should equal, plus the rest of angle A should equal up to 180 degrees. So I'm going to add 64 plus 49 together first. 9 plus 4 is 13. 6 plus 4 is 10, plus one more is 113. B and C together is 113. So I'm going to have to do 180 minus 113. Borrow and carry. 10 minus 3 is 7. 7 minus 1 is 6. To give me angle A is 67 degrees. Then it's asking me what is the measure of angle P. Angle P is congruent to angle A. So if angle A is 67 degrees, which means angle P is going to be the exact same measurement of 67 degrees. All right, and then last but not least, measure of angle Q. So we're going to go back here. Well, B and Q are equal based off of our rules to be similar. And if B is 64, Q is going to be 64. So over here, measure of angle Q is going to be 64 degrees. All right, then the last piece on this one is showing you something that looks like this. And here's what it's asking you in words. It is wanting to know, what is the measure of side A to B? As in, how long is side A to B on your problem? Which means we need to take a look. So if I know that QR and BC are similar, and if I look right here, if I go from QR to BC, I'll go from 23 to 46. Now I kind of have to think, how did I get from 23 to 46? Well, if I go back and if I think of 23 and if I turn it into 20, well, double 20 is going to be 40. Well, double 3 is going to be 6. So then I'm going to have 23 times 2 is going to give me 46. I'm going to erase this here so it doesn't freak y'all out later. So I know this information. So if I'm asked to find the side length of A to B, all I need to do now is go 19 and multiply it by the same number of 2, and that's going to give me my answer. So I'm going to do 19 times 2. 9 times 2 is 18. Carry the 1. 2 times 1 is 2, plus 1 more is 3. So the side length of A to B is 38, and this is inches. And then the same thing of A to C. I'm going to do the same steps here. I'm going to do 22 and a half, and I'm going to multiply this by 2 to give me the side length of A to C. So 22.5 times 2. 5 times 2 is 10. Carry the 1. 2 times 2 is 4, plus 1 more is 5. And then 2 times 2 is 4 once again. When you're multiplying with decimals, do not forget you have to see how many there are, and there's only 1. So move it over to give me a whole number of 45, and this is going to be inches. Then we're getting into the question where it's asking, what is the scale factor from PQR to ABC? Well, PQR is my little shape, so I want to know, what do I do to go from little to big? Well, we've already found it out. To go from little to big is times 2. Then if I were to go backwards, I want to know, what do I multiply my big number by to get to my little number? So if I think of this in math, what do I multiply 46 by to get me to the answer of 23? There are 2 ways that you can choose to solve this. The first way is putting this into a fraction of 23 over 46 and simplifying this number down, or, which you would get 1/2, or you can take your number here, turn it into a fraction of 2 over 1, and then flipping those 2 numbers, and that will get you the reciprocal, which will also get you 1/2. Both of those ways work, and they will get you to your answer. I would suggest to do the first way here, as it will help you greatly with your test. All right, question number 9. The 2 triangles are similar, find the missing measurements and the scale factor. All right, so we're doing the same thing again. So let's take a look. What is the scale factor from QTR to XYZ? Okay, so it looks like I'm going little to big. So I'm going to use 5 and 10. So 5 times what is going to give me to 10? Well, 5 times 2 is going to give me to 10. Now I'm going to go backwards. I'm going to go big to little. So 10 times what is going to give me to 5? So if I were to write this as a fraction, so 5 divided by 10, and go backwards here, which I can simplify that down to 1/2. So my scale factor is 1/2. All right, your scale factor always has to be multiplication, but you can use division to help you answer your problems, which is what we're going to do here. So if I'm looking at the side T to R, well, TR is corresponding to ZY. So if ZY is 20, and if I'm going from 20 to here, you either can multiply by 1/2 or divide it by 2. So 20 times 1/2 or divided by 2 is going to be 10. Then I'll look at my next one of ZX or XZ. Where is it? Oh, this one. XZ, and that corresponds to 13. Well, when I go from little to big, it's 2. So 13 times 2 is going to give me 26. Angle T, where's angle T? There it is. Angle T is corresponding to angle Y, and by the rules, if angle Y is 110, angle T is going to be 110 degrees. And then the last one is angle Z. Well, now we kind of have to figure out, well, if angle T and Y are the same thing, angle Q is going to be the same thing as angle X, which is going to be 50. So now I'm going to have to figure out what is the missing angle. So I'm going to add 50 and 110 to give me 160. Subtract that from 180, and you're going to be left with 20 degrees. So angle Z is going to be a 20-degree angle. All right, number 10, use the diagram below to determine the height of the flagpole. So this looks like a shadow method question. We're going to use height over distance in helping us with this. So I'm going to start with my flagpole. I don't know the height of the flagpole, but the distance is 7.5 is equal to the height of my stick of 4 over the distance of my shadow is 2.5. Well, 7.5 cannot go into 2.5 nicely, or I don't know the answer to that. So I'm going to use cross product of 7.5 times 4, and then I'm going to divide it by what's left over. All right, so 7.5 times 4. 5 times 4 is 20, carry the 2. 4 times 7 is 28, plus 2 more is 30. There's one place value, so I'm going to move the decimal to 1. And I'm going to have 30 divided by 2.5. 2.5 goes on the outside, 30 goes on the inside. I have to move my decimal over one time, create it, and move it over here, and add in a 0. 25 can go into 30 one full time. I have to borrow and carry. 10 minus 5 is 5. Bring down my 0. 25 can go into 50 two times with nothing left over. Giving me the height of my flagpole is 12 feet tall. Moving on to question number 11. Triangle DEF is an enlargement of ABC. I'm going to grab my highlighters again, and I'm going to start highlighting my corresponding sides. All right, so I'm going to go AB as red is corresponding to FE. BC is corresponding to DE. And then last but not least, AC is corresponding to DF or FD. And I'm going to write those information here. So I'm going to say AB is similar to FE. And that was my red side. My next side is BC is similar to DE or corresponding to that. And that was my blue side. And then last but not least, AC is similar to FD. And that is my green side here. Then I'm asked to look at my angles. Well, the easy one you can tell is angle B. I'm going to do this in colors so that way you guys can tell. Let's change it up. Angle B is equal to angle E. So angle B is equal to angle E. Angle A is the same thing as angle F. So angle A equals angle F. And then the last one is angle C, and that one equals angle D. So angle C equals angle D. All right, what is the scale factor from ABC to FED? Well, it looks like I only have two numbers that I can tell you of the corresponding sides, and that is 8 and 12. So I'm going to use 8 and 12 to help me out. So I'm going to go from little to big here, which means 8 times what can get me to 12. So I'm going to turn this into a fraction of 12 over 8, and I'm going to simplify from here. 8 can go into 12 one full time with 4 left over. You can simplify 4 over 8 into 1/2. So my scale factor is going to be 1 and 1/2. Then it wants to know the scale factor going in the opposite direction. So from going from big to little, or 12 times what is going to give me to 8. I'm going to write this as a fraction once again. 8 over 12. 8 over 12 can be simplified by, let's go ahead and do 2 just to make it easy. Half of 8 is 4. Half of 12 is 6. I can simplify this again by 2. Half of 4 is 2. Half of 6 is 3. Giving me my final answer of 2/3. You could have also simplified it by 4. That would have gotten you down to the final answer faster, but just in case, you can always stick with 2. All right, question number 12. It is asking me, if I were to go into these rectangles, is my scale factor, is the number going to be larger than 1, smaller than 1, or is it going to be equal to 1? As in, do I get bigger, smaller, or stay the same? So if you look at A to B, so if I'm showing right here from A to B, if I go here, A to B, did I get bigger, smaller, or stay the same? Well, from A to B, I got bigger, so it's going to be greater than 1. B to D, I got smaller, so it's going to be less than 1. C to E, well, C to E, I stay the same, so it's going to be equal to 1. E to A, I got bigger, so it's going to be greater than 1. D to C, I got smaller, so it's going to be less than 1. Then A to D, so I go A to D. I got bigger, so it's going to be greater than 1. And then finally, B to C, I got definitely smaller, so it's going to be less than 1. That's how you look at those types of questions. All right, let's flip on over to question number 13. Grab your highlighters once again, and let's go ahead and highlight our corresponding sides. All right, so I'm going to start with, actually, I'm not going to do that. I'm going to rewrite my triangle here. So I see that my triangle XZY is flipped upside down, so I'm going to flip it right side up. I know that Z is in this bottom corner with that, Above Z is X and below Z is Y. So I went ahead and flipped it to make it a lot easier when I am highlighting my corresponding sides. So C to B is corresponding to Z to Y. I'll even show you here. A to C is in the same place as X to Z, which I'm going to show you that here. And then our last one, A to B, is in the same spot as your diagonal of X to Y. So we're going to go ahead and write those here. A to C, not AB, sorry. A to C is corresponding to XZ, which that's your, whoops, not your green one. That is your blue one. Then your next one is CB is similar to ZY. That is your red one, or my red one, I'm sorry. And then the last one is AB is similar to XY. And for me, this is my green one. Then I'm asked to correspond my angles. So I'm going to take a look. Angle A is in the exact same place as angle X. So angle A is equal to angle X. Angle C is in the exact position as angle Z, and it also has that 90 degree. So that's a really good helpful tip when I'm looking at my angles. And then the last one is angle B, and angle B is in the exact position as angle Y. So angle B is equal to angle Y. All right, question number 14. It is asking me that I have the shape below on a grid, and I want to take this shape and I want to scale it. Whoops, sorry. I want to scale it by a factor of 2. So I want to take my original shape and I'm going to get bigger by a scale factor of 2. So the first thing I'm going to do is I'm going to go ahead and label all of my sides. So I have a height of 3, width of 1, height of 2, width of 1, 1, and 2. When you are taking your shape and you're going bigger or smaller, all of your sides are going to be multiplied by the same number. So I'm going to recreate my new shape down here. And instead of it being the height of 3, I'm going to do 3 times 2, which is going to be 6. So I'm going to highlight or shade in 6 squares tall. So 1, 2, 3, 4, 5, 6. Then I'm going to do the next one. Well, if it's a width of 1 and I'm going up by 2, well, 1 times 2 is 2. So it's going to be 2 tall or 2 wide. Then I'm going to look right here. It is 2 wide at the bottom. Well, 2 times 2 is 4. It's 1 height right here, so it's going to go up by 2. 2 wide, and then 2, 4. So when you look at your new numbers, you have 6, 4, 2, 2, 4, 2. Your new numbers that should match each of your sides now should be a scale factor of 2 or an enlargement of 2 from the original sides. All right, flip on over and look over at question number 15. The figures are similar. Determine the missing measures. All right, so we got to look for our corresponding sides. So I'm going to go ahead and highlight my corresponding sides once again. So I'm going to do AB is corresponding to LM. BC corresponds to MN. And then AC corresponds to LN. I'm going to go ahead and write these in. So AB is similar to LM. BC is similar to MN. And then AC is similar to LN. Now we're going to look at our corresponding angles. A is equal to L. So A is equal to L. B is equal to M. So angle B is equal to angle M. And then angle C is equal to angle N. So angle C equals angle N. We are asked to find the missing measurements of our angles and our sides. So once again, do not forget, if you see something that looks like this, it is reading to you of what is the measure of angle. And in this case, it's angle A. So if I take a look, angle A is equal to angle L. And if L is 50, that means A is going to be 50 degrees. Ooh, I don't know why that's like super big. I'm so sorry. is going to be 50 degrees. The measurement of angle M, so let's take a look. If B is 70, that means angle M has to be 70 degrees. Then if you see something that reads this, it is asking you what is the measure of side AB. So we've got to take a look right here. So side A to B. Oh, we already see that. Side A to B is 2. I'm pretty sure that was supposed to say A to C. I am so sorry. And then, or L to M. Then we're asked to find what is the side length of A to C. So in this one, we're looking over here. So I'm going to go ahead and set up a proportion. So I know what these two pieces are. So I'm going to go ahead and do 1.76 over 3.52 is equal to, well, green over green. If I went little to big, I'm going to have to do x over 4.34. And then we're going to cross product. Now, these numbers are super large. You will not have these large numbers on your test. So I'm telling you that I'm going to use a calculator to make it go by a little bit easier and to make sure. All right, so I'm going to have 1.76 times 4.34, which that's going to give me, I'm going to write it up here, 7.6384. And I'm going to divide that all by 3.52. to give me a final answer of 2.17. All right, and then the last two on this part is I want to go from ABC to LNM, so I'm going to go little to big. So I want to know 1.76 times what is going to give me 3.52. And again, I'm going to set this up as a fraction, so 3.52 over 1.76. I'm going to use my calculator just to make this go by a little bit faster, 1.76, and that's going to be 2. So my scale factor for my big one is times 2. So the small side times 2 to give me to the big side, and then I'm going to reverse that. So big to little, I'm going to do 3.52 times what is going to give me 1.76. So it's going to be 1.76 over 3.52. And when you do this in your calculator, you will get 1/2. So your scale factor from your little to your big is 1/2. All right, looking over at question number 16, you are given the parallelogram and said that one parallelogram is equal to the next or similar to the next parallelogram. We want to know which proportions can be used to find the value of C. All right, so if I were to take my highlighter and I'm going to highlight AP, ZW, 15, and 45. All right, so let's take a look. So if I look at this, 7 is in yellow or red, and then 15. And then 45 is blue, and then C is red. Did I go in the same direction for both? Nope, so A is not going to be correct. I'm going to use my pen here, not my highlighter. B is 7 over 45. Even if I look at this, oops, sorry, that's the pen, not the highlighter. I'm sorry, I'm getting used to this. 7 over 45. Even if you do go from one shape to the next, you have to go to your corresponding sides. Versus with B, it went from two sides that are not corresponding, so that's not going to work, which means that's not correct. All right, let's look at letter C. I have C, 7 over C. Well, I went in the correct direction here, so that starts off super good. Then I look down here, it's 45 into 15, but the issue with this one here is that I go from 45 to 15, which is not going to be correct, so C is not correct. Now I need to look at letter D. I go 7 over 15, so I do, nope, not blue. I'm going to do red over blue, which is perfectly fine because I'm going to show this in a different color. I go 7 over 15. And then if you look at the next one, it is C over 45. And even though you're going within the same type of triangle, parallelogram, you're going in the same direction, which would be true. So D is your final answer. All right, flip over to the very last question, number 17. It's giving you the picture of four polygons, and it wants to know which polygons are going to be similar to your A, B, C, D. This is very similar to the question of your WUMPs. So what I'm going to do to help us is I'm going to count the base and the height of this original shape here. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 10 here by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 10 here. We're going to go ahead and count the base and the height of all of our other polygons. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. I'm going to look down here. Oh, make that 4 a little bit bigger to see. 4 and 4. Then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, when you are scaling your shape from your original, so this is our original here, to make any of our new shapes, you need to multiply the same number to all of your sides. So if you look at the remaining 3 that you have, the only one that does not match as far as this, if you think of a square has all the sides that are the same. Our first polygon, our original, is a 10 by 10, which means when I multiply 1 10 by, I have to multiply the same thing. So it's going to go bigger or smaller down to the same number. The only one that does not match it is LMNOQ. That one is a 10 by 8, and where all of the other ones are 8 by 8 or 4 by 4, which is a matching double number that you have. So if I'm looking at this correctly, KLMN is not 1, so PQRS and FGHI and J. Both of those are going to be correct as far as similar shapes. If you have any questions, please see us for help.